Welcome to Catnip Earl Lab. This video is all about texture transitions in Blender. It might sound a bit confusing at first, but sometimes everything in Blender, textures, transitions, even simulations, all comes down to just 1 and 0, which makes me start thinking maybe we're all living in one big Blender scene, or a matrix. All right, let's dive in and master the magic. So right now we've got two materials with totally different looks. You can absolutely use your own materials here, or if you'd like to recreate these exact ones, check out my previous video where I show how to build them from scratch. Before we go further, let's quickly understand what vertex weight is. When nothing is selected, you'll see the mesh in blue. That means there's no weight, or a value of 0. Once you start painting on the object, the areas you paint will change color, turning red where the weight increases. Blender automatically creates a vertex group to store those weight values for each vertex. Now let's set up the synchronized texture and Puffy transition. Let's add a vertex group and assign it to the whole mesh first. Then we'll quickly create an empty object. We'll use it later to control the effect. After assigning all the vertices to one group, you'll notice the whole mesh turns red. That means every vertex has a weight of 1, or full influence. If we lower the weight value to 0 and start painting, you'll see blue areas appear. Blue represents 0 influence. Basically, each vertex in a vertex group stores a weight, which is just a number between 0 and 1. 0 means no influence at all, 1 means full influence, and anything in between gives partial influence. It's what we'll use to smoothly control both the texture transition and soft puffy effect. Now let's add a vertex weight proximity modifier. This modifier calculates the distance from each vertex to a target object. In geometry proximity mode, the highest parameter defines the range of influence, how far the empty can affect the vertices. The closer a vertex is to the empty, the lower its weight value, closer to 0, and the further away it is, the higher the value, closer to 1. Next, let's keyframe the empty's movement. As the empty moves, you can see its influence area, a 1 meter radius, shifting across the mesh, showing which vertices are being affected in real time. All right, now that we get how it works, let's keyframe the lowest and highest values. There's one more thing. When the lowest and highest values are close together, the transition area becomes much narrower. That means most of the vertex weight is either 0 or 1, making the effect snap in really quickly. When we increase the gap, more of the mesh gets values between 0 and 1, which creates a more gradual transition across the surface. I want the effect to appear like it's coming from the bottom, so I'll adjust the empty's position. This time I'm going to set the gap relatively small. Now comes the cloth simulation part. Let's set it up real quick and jump straight into the interesting part. At first, it's just the usual puffy animation. Nothing's pinned, meaning every vertex is at 0 weight. But once we pick our pin group proxy weight, the values transition from 1 to 0, going from pinned to unpinned. And that's exactly what we see happening in the animation. Next, we can use the powerful yet simple geometry nodes to capture and store the information we've set up so far, so we can pass it over to the shader editor later. The capture attribute node is what we'll use to record values. Then, using a named attribute, we can bring that data into the material. It's basically a clean, modern bridge between geometry nodes and the shader, letting the material read our custom data, like the procedural transitions we've just built, perfectly in sync. I've just brought the two materials together and added a mix shader. Right now, they're simply blended because the FAC value is 0.5. Meaning both materials are mixed evenly. If the FAC is 0, we'll see the first material, the stripe texture. If it's 1, we'll see the second one, the purple metal. Yep. Same story as before. Everything runs between 0 and 1. All right, let's grab the data we saved earlier and feed that 1 to 0 transition into the mix shader. We can also duplicate the mix shader to add an emission texture in the blending ring area. This lets you create a glowing transition and add more dynamic detail to the animation. The current edge looks jagged because of low mesh density. You can either add more vertices to smooth it out or use a color ramp to control the influence range more precisely. For the last part, ice to fluffy fur transition, I'll invert the weight values, changing them from 0 to 1, and use that to drive the hair length in the particle system. Here's a quick demo to show how it works. Thank you for watching. If you like this video, don't forget like and subscribe.